Okay, so we're going to probably finish up most of chapter 10 today. I don't think we're going to get to the unit testing stuff. I want to do that, I think, a little later, because I think it's very important that we learn that stuff. But we can take a pause right now because we need to prepare for the exam and the instance stuff. The stuff we're talking about today, this is not on the exam. None of this UML stuff is on the exam. The exam is just functions, files, and classes. All right, so as a recap, we talked about this thing called UML, which is how we write the blueprints for our application, for our code. And it was pretty simple. We have these boxes where we put the class name, then we put our attributes, and then we put our methods. Really, the only thing to remember, for attributes that are public, we say plus. For attributes that are private, we put a minus sign. And typically, our functions or our methods would have an underscore in it, or our attributes would have an underscore if our intent was to make them private. It's a bit hokey in Python because there's really no concept. There's no way to enforce that. But do remember this, when you move into your first Java class, this stuff is very, very critical that you discriminate between public and private and something called protected, which is like in the middle. In addition to representing a class, we also talked about how classes are associated to each other. And so we looked at this notation here. And I'm not going to go really hard on this because I know it takes a little getting used to. At a minimum, if you kind of just have the arrow, I'll say, yeah, that's good enough. You're showing me some understanding. But we do want to appreciate there's a difference between a has a and an is a relationship. So a restaurant has a menu. I think we can all agree a restaurant is not a menu, right? So a restaurant has a menu, and a menu has menu items. And there's a little subtlety. You know, we say one is an aggregation and one is a composition. And the real difference is, you know, a menu really can't exist without menu items. And menu items really can't exist without a menu. But a restaurant can certainly exist without a menu, and a menu can certainly exist without a restaurant. These has a relationships. The one really, really key thing you want to pay attention to, though, you really should make sure you have some sort of collection on the owning class. So we should see that this restaurant has one or more menus. We should see that this menu item or menu has one or more menu items, right? And so that typically means you're going to have an attribute that's some sort of collection, a list or a dictionary or maybe even a tuple. So the big difference between the has-a and the is-a relationship is a subclass, a derived class, a specialization of. So we can sort of say a breakfast menu is a type of menu. A lunch menu is a type of menu. And we'll look at a couple more examples of that later. And I apologize. I know I sped through class how to use that draw.io thing in order to generate those diagrams. I put together a video. It's out on course content. So it walks you through a lot slower how to not only launch draw.io, but how to export the images from it. Because what you're going to have to do in the next assignment is you're going to write these. You're gonna write some of this UML, and I'm going to say, hey, I need you to paste that into EdStem. And it's pretty basic. You know, after you kind of make your diagram, you'll just say export as PNG, right? And then you'll just say, oh, I just want to export this page. And you can either export it to your local computer, or if you want to keep it in Google Drive, you know, whatever. And it'll just, you know, download the file locally. So, fair bit of detail in there if you want to watch that video. Otherwise, it's kind of self-explanatory. All right. The last thing we got up to on Wednesday was that concept of the derived class, right? So we looked at the diagramming where we said a breakfast menu is a menu, right? And so we started to look at this example of, well, there's different types of people. So syntactically, if I'm going to create a derived class, the syntax really has two parts to it. Number one, my derived class, and it's kind of sucks that it's this way, but it looks like a function, but it's not a function. So a gamer is a type of person, a subclass of a person. That's the one thing we have to remember when we create a derived class. The second thing we have to remember is we have to call the constructor. We have to explicitly call this init method on our parent class. Again, I really, really hate this about Python because you can forget to do this. And if you forget to do this, and you'll see in a minute, like you won't have access to these attributes, you won't have access to these methods, and it jacks everything up. In these stronger type languages like Java, you can't make that mistake. You're forced. They will force you to call the constructor on your parent class. But in Python, you can screw it up. So we have to remember when we create our class, our subclass, parentheses, whatever the name of our base class is, and then we call the constructor of our parent. All right. So a little bit more about accessing these attributes of our base class. So let's look at another metaphor here. Let's say I have a parent class called performer. There's musicians, there's actors, there's poets, there's everyone. I'm going to make a claim that abstractly they all have a name and maybe they have a rating. There's a subclass of performer called musicians. So musicians inherit all of the attributes, all of the methods of its parent, but it has some additional flavor to it. So a musician has a music category. And you can do this ad infinitum, but I'll make the claim then a type of musician is a guitarist. And I want to know about my guitarist, what type of guitar they have. I'm being a little fast and loose. I'm not showing you how this stuff is implemented, but you should be able to make a reasonable guess. If I instantiated a performer, the only thing I have access to is name and rating. So not every performer is a musician. So it doesn't make sense if I create a performer that has a music category or a guitar. But if I create a musician should have access to that music category. And then finally, the guitarist should have access to everything that's in a musician, everything that's in a performer, right? Likely, it's not required, but likely what your constructor is going to look like. Your constructor is pretty much going to look like your attributes that you have for performer. It takes two things. Musician takes three things. The thing that's unique to itself plus what's on its parent. And then finally, the guitarist takes what's on its parent and on its grandparent. Doesn't have to, but it usually does. I guess you could think it's kind of like, it would be weird to have a guitarist that doesn't have a name, right? And so you're doing this so that you can kind of put common logic up here. So let's take a little look at it. And, you know, again, with all this stuff, I stress this. I find this is becoming very important, like now with the project. Please make sure you're going back to the previous assignments, like specifically these like freebie 1-point problems. I hear a lot of people say like, oh, shoot, I forget how to access an element in a dictionary. We'll go to assignment 3 on types. There's a whole section on dictionaries. And I'm like, hey, this is how you construct it. This is how you access the value, stuff like that. So do take advantage of this stuff. And if if you're not coding along here, which is totally fine, they all should have the solution here. So what I'm actually typing, I've typed out already, right? So you should be able to kind of get this good stuff. So if I was to create these classes, what I would normally do is I would do a top-down approach. You can do top-down or bottom-up, but if I start with the guitarist, I might like have to do extra work in my constructor later on. So I'm going to start with the performer. So I'm looking at my diagram. Class, performer. I'll put some placeholder for my doc string. Definite. Self. It takes a name. It takes a rating. Remember, these are the parameters. They're not the attributes, which is what's in my diagram. In my diagram, I want to make sure this says name. I want to make sure this says rating. Now there I say that's private, so I probably want to say like rating like that, right? But if I wanted to, I could make my parameter N, I could make my rating R, right? There's nothing wrong with doing that. It's just more common to do that duplicative, like parameter name, attribute name, parameter rating, attribute rating. All right, so I have that, and then I would go ahead and I would stub the next method, def perform. Remember, all these always have to have self in it, right? And then do pass. Pro tip, because again, I talked to a couple people about this. When you're doing like any of these assignments, if you see me say, hey, add a method called add item, add a method called remove item, stuff like that, like at a minimum, just do that. You'll get a whole bunch of points. Like I just want to make sure you know how to like basically create a function. Sure, the logic is important, but I do need to make sure you just understand the basic structure, and you're not doing stuff like, putting this out there, right? Okay, so on my theme of iterative development, I'll run that and be like, okay, I have some sort of problem here. Indentation after line 15. So what am I missing? Oh, okay. I can't have a block without something in it. So this is complaining about my main. Okay, looks good. Let me create some performer. Go back to my Latin days. Let's say Cicero, old school poet. Okay, nothing broke. All right, I'm lazy. My next step here, I can sort of memorize what's in that picture. So I'm just going to copy my performer. And my next level of abstraction here is my musician. Notice where I'm putting it. Like, I'm not required to put this like above or below the main, but it's really uncommon to like put a class up here, have your main, put some methods down here. You typically like put your classes up top, you put your functions up top, and you just have main at the bottom. So here I'll create my musician. And we said musician took an additional music category. Self.music category equals music category. Now, the difference here, right, is I don't want to go ahead and store this stuff on my musician instance. I want to say here who's my parent. So it's performer.init. I want to pass myself, and I'll pass that N and that R parameter. While I'm doing that, I'm like, ooh, I made a mistake. What did I forget to do in making a subclass?
Next musician.
Yeah, I forgot to make him a performer, right? So I just drop it in there. Now if I run this, cool, I can have a performer. And then I can create some musician. Dell, I don't know, she has some category, whatever, we'll say soft rock. Okay, got a problem here. Performer init takes 3 parameters. What did I forget? Self and R. Let's see. Anybody see my mistake? Because I'm having trouble seeing it. What's that? Oh, down here. Oh, this is my problem, actually. The problem is here. I want to make him a musician. Yeah, musician takes 3. It's even telling me 3 arguments, but there should be 4. So, okay, cool. So I have my performer, I have my musician. So now, again, notice here my musician. Nowhere here do I have their name, but I can access it. So I can say, you know, m.name, right? So that's a del, right? And you can imagine, you know, we can look at the solution for it. We can go as many levels deep as we want. So if we went down and created that guitarist, you know, it'd be the same pattern here. Okay. So if we can override attributes, and notice the word I'm using, overriding. You can say overriding or overwriting, kind of synonyms there. If I have a person, and I have a subclass of person, this gamer, I can also override these methods. So we can all agree that a person probably has a function called eat. But if I create a gamer, maybe I want to say, you know, gamers need no food. So that's what I'll print out when I call that function. So I have a class named person with a constructor and an eat method. I have a class called gamer, which is a subclass of person, has a constructor, calls the parent constructor, has some additional attributes, games, has an additional method, play, and the method eats. When I instantiate my gamer and I call eat, that's going to call this method, right? It's not going to call this method. So back to this pattern we were talking about where we have the local scope, the global scope, the built-in scope. You're kind of always going from the bottom up. So what is the most specific information I have about gamer? Well, it's a gamer. So I'm going to call that method, not the one on my parent class. And we'll do a little Python tutor, I think, for that. Oh, actually, that comes in a second. So with methods, there's the concept of overriding and the concept of extending. So when I override a method, I'm basically saying ignore everything that's done in my parent class. So in this implementation of musician, if somebody says perform, I'm going to print out the message he's playing music live rather than performing live. So I'm overriding, right? So like nothing exists in the performer. But often the reason why we have derived classes is we want to leverage what was done in our parent class. So instead of overriding, we call this extending. So in this particular case, when somebody calls on my musician perform, I'm going to have it do the action that's on my parent. So I use the name of the class, the method I want to call, and then I do my own thing. Python's kind of fast and loose, and again, it's another area where you can potentially make mistakes. It doesn't enforce that you call the method perform. If I had another method called eat or something, I could accidentally call the perform method on my musician, and then I coded it up where I said eat. So, kind of sucks. Other languages wouldn't do that. Other languages, when you have that hierarchy, it would sort of make it easier for you to call the parent. All right, so let's try to distill this a little bit. This is the same code we were just looking at. So I have my class performer, I have my class musician, and right now I've commented out the perform method on my musician. So what happens here? The interpreter acknowledges there's something called performer, but it doesn't actually execute any code. It acknowledges there's something called musician, it doesn't execute any code. So here, it instantiates a musician. It goes into the musician's constructor, which, because I coded it, goes into my parent's constructor, right? So this musician instance here, in a second, it's going to get two attributes. So it has a rating and it has a name. Now it has a music category. That's something specific I had on my musician. When I say perform, this will print out whatever was done in my parent class. So Hendrix is performing live. Now, the concept of overriding is this. I take my method and I do something different. So now when I get down to this point where I'm going to call perform, I instantiated my musician. Now the interpreter's like, wait a minute, I'm going to check the local scope first, then the global, then the built-in. It's similarly going to say, ooh, I'm going to look at my derived class, then I'll go to my parent, then I'll go to my grandparent, and so forth. So here, it's going to fall into the base class, the derives class, and say, Hendrix is playing music live. So that's overriding. I kind of like overwrote exactly what my base class would do. Finally, the concept of extension here is me just calling the method on my base class before I do my own secret thing. So now, when I get down into this perform method, it falls into the parent, prints that out, and it prints out my own special message. There's one other thing. I don't think Zybooks talks about this. This is really what other languages would look like. You would say super, and you'd ignore this self parameter. So when I do this, when I fall into this perform block, super is sort of a shortcut way of saying, find my base class and do this thing, right? But I think Zybooks avoids you doing that because it looks totally different than any other method in Python. Because like I'm not dealing with that self thing. But I get comfortable with that because that's how every other language in the world does it. They use this concept of super, which just means like what could bug me. Okay. Related to derived classes, I hate this. This is horrible. Most people who design languages hate this as well, and they avoid this problem like the plague. Zybooks gives you this concept. They call it mixins. It's basically multiple inheritance. The example in the book, they say a bat. They say a bat can equally be described as a mammal and a winged animal. Fair point. And I kind of tried to think of another example. This is probably the best I could come up with. We can all agree there's a concept of a coffee machine. What do I need for a coffee machine? I need water. I need coffee. So I have some amount of water, some amount of coffee. And I have methods brew coffee, refill the water, refill the coffee. A latte is slightly different than regular coffee, and an espresso is slightly different than coffee. I'm not a huge coffee person, but what discriminates a latte from a coffee? No. What discriminates an espresso from a coffee? Beans. Yeah, it's like more grinds. So you can make the claim that a latte is sort of, it's equally important that I have this milk thing, but I also have the core coffee. An espresso, it's equally important that I have coffee, but also the extra beans that I need for it. So basically you're saying this thing has multiple types of parents. Python tries to be cool about it by saying, well, we're going to say one is more important than the other. There's like a latte is really closer to coffee than just a milk frother machine, right? It's like, if it's just milk, it's not really coffee. If it's just beans, it's not really coffee. So there's a base class, but sort of the lesser priority base classes, they use this suffix mixin. Not required to use it, but it's just kind of the syntax or the convention. So I have a class called base class. I have a class called Mixin Class 1, class called Mixin Class 2. This is super simple. All I do when I'm creating my subclass is I first list out what my base class is. What is the primary thing my base class is? The latte machine is primarily a coffee machine. Then I just put commas and I put all the other mix-ins. In my constructor, you typically, you're not required, but you typically just call the constructor of your base class. You could call the constructor on your mix-ins, but you normally don't. You normally just use the mix-ins for extra functions, for extra methods. The reason why everybody hates this is because it's confusing. What happens if you have the same method on your mixing class as your base class? Like, which one is going to get executed? And Python just says, okay, listen, same thing with like the scoping thing. It's just hierarchical. So if you want to call the method 1, it's going to go to my subclass. Say, oh, I don't see a method called method 1. Okay, I'm going to go to my base class. Going to look in here. I don't see a method 1. Okay, I'm going to go to the next mixin. Oh, here. There I have a method 1. I'll execute it. Right? So if I had a method 1 up in my base class, it would have called that one first. So the same thing happens with attributes, but attributes are even worse. Attributes are even worse because, like I said, typically, you only call the constructor on your base class. If you don't call the constructor on your mixin or your other class, you simply won't have access to those attributes. So I know we're kind of at time here, but I'm going to leave that here. You can step through this code. You have the link. I'm not going to require y'all to create mixins. I might have like a question or two on the next quiz. This stuff is just horrible. I mean, it's so confusing. I'm kind of respectful that Zybooks has it there, and you should appreciate the concept and why it really sucks. So when you go to other languages, you're like, oh yeah, this is a lot better when I just have one like parent class. Unit testing, I want to spend a good deal of time on that, so I'm going to skip that until after the exam. So directly after class today, I'm offering up some extended office hours. Maybe wants to come over to 454. A lot of us have been making progress on project 1. Hopefully the people who have done it, you can tell your friends here. Once you get the first one, the other ones just, I mean, it'll take you like 5 minutes once you get the next one. Okay. That will be due Sunday at 11 p.m. I will have out sometime this weekend the exam prep. Monday, I'll be doing another code jam at night. If you can't make that one, I'll be doing it Tuesday. And the exam will be on Wednesday. Yeah. I'm going there right now. I'll be there until about 5. Yeah.
So using like your examples,